Thank you guys for having us today. I hope the weather still keeps you inside a little bit. It's cold in here, and we are happy to be back at WAD this year. We've been part of WAD last year in Vienna, and I think it's a great chance for us today to basically show you the progress that we've made since then. We'll talk about a topic that is titled here, so you see it here, data-driven and cloud-native ecosystems in the automotive industry. Very buzzwordy, so what it means in simple terms, it's really about our migration of our data lake and big data platform to the cloud, more specifically AWS. It's going to be me, Joseph. I've been with BMW Group IT since roughly 3 years. Prior to that, I was actually working in Munich as well for Allianz SE, where we migrated the big data stack to AWS in a very similar fashion. I'm going to have on the stage join me Patrick, who has been roughly 3 years at BMW too, and he's one of the lead architects of the cloud data hub there too. Now, this is our agenda today. We'll start with a very short introduction of the BMW Group IT. Talk about the motivation why we actually started the Cloud Data Hub initiative, and then I'll hand over to my colleague Patrick. He'll actually give you some deeper dive into the architecture, into the kinds of data that we process, vehicle sensory data, so all very, very interesting aspects that we'll deeper dive today. And I'll actually afterwards conclude with a couple of lessons learned and concluding notes. Now let's hop over to a brief introduction to the BMW Group IT. Well, evidently it's a sub-branch of BMW Group. The BMW Group, namely, it has roughly 125,000 employees worldwide, so it's really a global organization with many, many locations worldwide. And the BMW Group IT itself is an organization with an international footprint too. So we have 5,000 employees worldwide. Well, it's dominated by Bavarians still, so 60% of these people actually working in Munich. We are headquartered in Munich, but we have tech offices in Mountain View, we have tech offices in Shanghai. We've recently, actually in 2018, partnered up with Critical Software in Portugal to establish the Critical TechWorks joint venture. So we are based out of Porto and Lisbon as well. And I think at least the 3 years I've been with BMW have been very interesting for me, working with so many different people and cultures. Now let's hop over to a couple of other facts and figures. So we have 60 nationalities in 29 countries. There are much, much more locations than I've been pointed out before. We have 230 software products, and actually our VPs, Christoph and Frank, have been giving a presentation yesterday about software products, and we are proud to be one of them, being able to present you today the status about the Cloud Data Hub. And I think the most important takeaway from that slide is really that as of today we are coping and we are handling 1 billion requests from 12 million vehicles all over the world on a daily basis with the Connected Drive backend, which basically powers the entire Connected Drive BMW fleet. So that's, I think, is amazing. And Connected Drive, as part of that, it's one of the most important data delivery units. So it provides us with more than 500 million messages on a monthly basis. So that's a lot of data that we have to digest. Now let's hop over to the motivation, actually. So actually let's take a few steps back. 5 years ago, we've actually, prior to adopting cloud, we've been ramping up the on-premises data stack. And traditional on-premise big data stacks, they started with actually introducing Hadoop at the core, right, for good reasons. IoT, relational data, we're interested via using tools inside of the Hadoop framework like Scoop and Uzi, and frameworks and languages of choice like, for example, Pig, Hive, and Spark. They've been used for actually munging and wrangling the data, such that we could actually really work with the data and build use cases on top of it. However, quickly we've seen that we had to introduce fast caches to be able to cope with the different stakeholders' requirements, with current and future demands for the platform. And we've seen a lot of in-memory databases come and go at BMW Group. I think it's the same for any of you sitting here working with data. So it ultimately actually leads to a very fragmented, very, very heterogeneous on-premises stack that you have to maintain, consisting of Hadoop, Kafka, consisting of various Postgres databases, Oracle databases, and in-memory databases that you have to maintain. And moreover, due to the bus about containerized workflows, we've been adopting actually Kubernetes and Docker to really be able to expose analytical insights via web UIs and microservices instantly. Good. So what that ultimately leads to is really a limited and very rigid tech stack that your developers and your business stakeholders have to cope with, right? So you have a very rigid framework in which you press your use cases, and you have multi-project, multi-tenant environments that you have to maintain. So it's also operationally very expensive to maintain such a tech stack. And at the same time, it doesn't give enough freedom to the developers and stakeholders to really build up what they need. In most of the cases, Hive is too slow for any kind of Tableau or ClickSense user, and Spark is only used by experts that really implement their programs with Scala and PySpark. Now, hopping over to operational complexity, I've briefly covered that as well. I mean, ultimately, you end up spending a lot of efforts, both internally and externally. You're spending money on actually operating and maintaining and running a stack that is not really differentiating. So I would say that many of the organizations that have on-premises big data stacks, they have below average or quite mediocre platforms due to the investments that they make to actually tuning the platforms and being able to cope with all the different requirements. And that's actually much easier if you move towards and actually adopt cloud services. Now, this brings me to the last point here. So it's really limited team autonomy, right? So ultimately, what you introduce is a lot of dependencies with your DevOps team. They have dependencies to the people who actually do the ingest. They have dependencies to the multi-project environments, whether it is Kafka, whether it is the Hadoop system at the core. So people do not have the freedom to actually, own the whole lineage, have the end-to-end responsibility, and have the end-to-end authority to actually execute use cases. And actually, by building up the Cloud Data Hub, we've noticed that we can make things much better, and Patrick will deeper dive into that from an operational aspect of how that actually looks like. So we're actually shifting, bottom line, we are shifting the focus towards innovation and differentiation by actually using cloud services off the shelf. I've mentioned it before. Our first partner here is AWS. So we're introducing the shared responsibility model, where, as opposed to a left-hand side, where many of the things that we've done were targeted towards maintaining an infrastructure, maintaining the platform on top of it, maintaining shared services like, for example, Jupyter, multi-user clusters, where actually people could do data science, and also the Kubernetes clusters that we have. So there's a lot of effort actually going into all these kind of non-differentiated heavy lifting workloads, and there is very little room for you to innovate on top of that by actually introducing and implementing differentiating services. Now, what we actually want to do is really focus on the differentiating bits and pieces that you can see over here. So, for example, building out recommender systems that make your services more intelligent and be able to adapt actually to customer needs. So that's actually what all the insights that we gather from our connected vehicles gives us, is really the flexibility to act on top of that data, and that's only possible if you spend enough time on the upper part and really diminish the efforts that you have on the lower part. So in terms of infrastructure as service, one of the major advantages that we have by moving towards the cloud and adopting cloud here is really the separation of compute and storage. Patrick will outline that later on a little bit in further detail. We are choosing off-the-shelf services from AWS to be really flexible and have speed in terms of building up a managed data lake, building up managed Kubernetes to be able to give developers exactly that what they want. And in terms of high-level commodities, we're actually looking at introducing tools like, for example, SageMaker that make model deployment topics much easier, as we've seen that before. Now that basically comes with three major aspects. So we are doing that in an iterative and agile fashion. So as of now, we've basically migrating 25% of all of the connected drive data that we are collecting on a daily basis to the cloud. So there's already a lot of effort that has been flowing into building up the AWS-based data lake. Secondly, it gives us sufficient technological flexibility to really support our users on building up use cases. It gives us enough flexibility to cope with the requirements from our business stakeholders that are very heterogeneous. And thirdly, we are not doing this by basically lifting and shifting the existing on-premises environment to the cloud, but rather we are re-architecting the big data stack that we've seen so far. Now, actually, our mission is to basically transform BMW into a data-driven company. That's at the heart of our mission. And this transformation is based on 4 pillars. So the first one is really data. Data is the major ingredient for us as being the data platform within the company, and that is really required in both high quality for both raw and refined data that can be used for any kind of data-driven decision making that we have internally. With vertically integrated solutions actually that are built upon machine learning at the core, insights need to be exposed very quickly and efficiently. Enabling people to exactly do that is really the key in building up a data lake strategy. Well, as you've seen before, cloud capabilities really built the foundation for being scalable, for being flexible, for having good developer velocity. So it ultimately leads to coherent, reproducible stacks that are very hard to actually rebuild on premise. So speaking of Terraform, speaking of CloudFormation, these are all components that we use natively in our DevOps teams to make sure that once we roll something out in the Europe region, it's just another click basically to roll it out in the US region too. Lastly, these days it's not about historicized data anymore that you basically ship to HDFS via various ways. It's really about making use of APIs and giving developers the freedom to consume APIs to ultimately enable them to tap into data quickly, independently of whether data resides at rest or in motion. So that's here really core and key. So I would now like to introduce Patrick, and he's going to follow up with a couple of architectural details. Please, Patrick.
Thank you, Josef. Yeah. So I would like to start by giving you a high-level overview about our architecture. Our architecture consists mainly of 2 different zones. On the left, you can see the real-time zone where we're having a batch state of data. The inside zone, we are having historized data that are mainly used for analytics purposes. On top of that, we are providing unified APIs that can be used from our customers to retrieve data from the data lake. By designing the data lake, we have been followed by the 3 guiding ideas. Firstly, democratization. We are training our colleagues so that they are able to interact with the Cloud Data Hub in an easy way. And secondly, modularity. We are providing best practices by creating building blocks out of our core team that have been proven. These building blocks should make life easy for the developer to start to ingesting data into the data lake, but also to consuming data out of the data lake. Thirdly, lean ops. We want to embrace cloud nativeness, and we want to use as many high-level services as possible. Now you can see here a bit a more deep dive onto the architecture. You can mainly see 3 different account types. On the left, you have the data provider that are basically mainly in charge on providing data to the data lake. In the middle is a single point of truth, the Cloud Data Hub. Here we are providing 2 different or multiple different storage possibilities, like storing data in batch as in S3, or having streams in Kinesis. We are also creating APIs that can be used to interact with the Cloud Data Hub. For example, data provider can use these APIs to create new resources like an S3 bucket or a Kinesis stream. On top of that, we are also we have created already a self-service portal that is mainly a first touching point where our customers or our colleagues can interact through an UI with the data lake. When we are speaking about a data lake, data cataloging is also an important point. You need a catalog to know what data you have in your data lake and how data have been evolved over time, basically the data lineage. Community is also an important point about around the Cloud Data Hub. We are building such a community, and we have also provided a website, developer.bmw.com, which is mainly an in-house website where our colleagues can see best practices and getting started that have been written from our team. On the right, then you see the data consumer. Data consumer have the freedom to choose their tools they would like to use, and that fulfill best their requirements. Whenever data can be retrieved through APIs from the Cloud Data Hub into the data consumer accounts. When a data consumer gets or creates new data insights, he can feed back these data also into the data lake, so that our other colleagues can make benefit out of that. Now I would like to speak a bit about how we are processing data from our connected vehicles. On the left, you can see vehicle telemetry data, basically two different sources. CDC data is the crowd data collector, where we basically can define today what data we want to retrieve tomorrow. Here we are getting a variety of signals out of our vehicles, and they are getting pushed directly into a Kinesis stream that resides within a data provider account. Second source is the last state call, so basically the last state of a car. Here the data resides on-premise in the Kafka, and we have deployed through Fargate a Kafka consumer where we are pulling out the data of the Kafka into a Kinesis stream. Privacy of our customer is important for us. Therefore, all data that we are storing within the data lake are getting anonymized by default, and we are only processing data where we have the consent of our customers. And of course, we are also taking GDPR seriously here. After first processing, we are mapping all these data onto a data model. That data model, I will show you that on the next slide, will be also stored into the different zones. So basically in the inside zone, where we are storing the data through a Kinesis Firehose as packet on S3. That helps us to querying these data in an easy manner. So basically SageMaker and also Athena or EMR can query that data in a pretty easy way. Within the real-time zone, we are storing the cache state of a car. Here we are storing that data in a DynamoDB, mainly for having a fast access to that data. And on top, we are using GraphQL interface for querying data. But we have also traditional APIs that have mainly built out of the requirements that we got from our consumers. As soon as the data are within those zones, it can be retrieved from various microservices that are processing that data and feeding back the data into different applications that are running within the car as connected drive applications. Here you can see such a data model. That data model has been inspired for us from, so it's basically the vehicle signal specification that has been published from W3C. And that allows us to map all the vehicle signals and attributes that we are getting from cars onto a coherent data model. That data model can then also be used for consuming from our consumers, and makes life also for them easy, as they don't need to process raw data. Here you can see, for example, an example of a GraphQL where we have a query that is querying these data. The good thing here is that we can fulfill with GraphQL a variety of heterogeneous requirements from our customers. They can basically query the data and also define what payload they would like to have within their applications. Last but not least, the self-service portal is the first touching point for all our colleagues that are working with the Cloud Data Hub. After you have been logged into the self-service portal, you will see an overview of all your roles that you have within your AWS accounts. And from here, you can simply log into the AWS Management Console or retrieve temporal credentials for the CLI. Data cataloging is also integrated within the self-service portal. You can browse your data, querying data, and get to know what data sources are available within the data lake. Last but not least, also managing data sources, basically getting access to specific data sources can be requested here. And now back to Josef, who is going to conclude our talk. Thank you.
Fantastic, Patrick. Thank you for running us through a couple of deeper dives here for the architecture. I'll now continue with a couple of design decisions, lessons learned. I think that it's always worthwhile to really reflect what has been going wrong, what has been going well. Now let me briefly reflect here a little bit on these points that I have here in the slide. So infrastructure as code, for example, that's always one of the key topics if you move to the cloud, right? That's always preferable of any kind of manual operations that you actually do. We leverage actually Terraform, not CloudFormation actually, plus the CI/CD pipeline to really make sure that once we have rolled out something in Europe, I was briefly touching upon that before, we are also capable of actually rolling out the stack in the US. While China is a separate topic in any case, but at least that you have reproducibility is one of the major important points here. I think one key aspect here is that with the AWS Management Console, so essentially the web UI and also the CLI, you can actually do great stuff. You can actually build things quickly. But as soon as you want to move from dev or sandbox to something that is int or prod, I think using Terraform, CloudFormation, whatever you guys prefer, is something that I would highly recommend. Now the second one is cloud managed services or custom infrastructure. I think that has been outlined by Patrick in much detail by giving you a deeper dive into the individual cloud services that we use. And in simple terms, it's really, we prefer Kinesis over operating a Kafka. We prefer a DynamoDB over operating a MongoDB ourselves. And the reason is that every component that you actually introduce into your stack that is not managed requires similar terms of operations as you have it on-prem. And for streaming data, for example, we've mentioned it before, we prefer Kinesis over Kafka. Kinesis is a great piece of technology, and also there's managed Kafka if you want to have something more managed, if you do not want to manage it yourself on AWS. And things like high availability, things like maintenance, patching, in most of the services that are at a certain management level within AWS and other cloud vendors, certain security aspects and things have been taken care of already. And also we deeply believe that serverless is going to be in any case the future. So at some point in time, you do not want to care about how many nodes you have provisioned for a Redshift, but you basically just say, okay, I want to run Redshift. I want to be able to provide coherent interfaces to my stakeholders, and that's it. And the ultimate goal here with the second point is to avoid any kind of undifferentiated heavy lifting at all costs. Simplicity and replaceability over pre-major optimization, I think that very much addresses, being in a German automotive, well, there's a lot of planning usually involved. If we look at the last 10, 15, 20 years or so, especially if you look at the production process of producing cars, well, there's always a long lead time and there are certain milestones that you have. We have these milestones as well, but it's far more agile. And I think for us, it means really that, managed services, they really ease the efforts that you put into operations, but they are pretty cost intensive on paper, right? But if you put the TCO perspective afterwards on top of these things, if you say, okay, well, on-prem, I have these types of FTEs of efforts flowing into maintaining and operating a stack versus how easy it can be while moving to the cloud, I think then things are for sure different. In any case, it's not always to really, put the hard number on the number of calls that you will receive. So, we've been going through a lot of trial and error, being able to cope with all the requests from our connected drive backend. And helpful is it here really to basically iterate and then plan. So, you can introduce something like a Lambda before. And if you see that it doesn't scale, then you can replace it later on with going to ECS or going to Fargate. So that's always a good approach here. Now, well, I've mentioned that before briefly. So we think anyways we are leaning more towards the right-hand side, so really going towards serverless, even full serverless. We've had our journey with on-premises. We've had our journey from moving and shifting and lifting on-premises workloads to the cloud by using EC2, for example, so simple virtual machines. We've also had kind of the intermediate state where we actually went to OpenStack and OpenShift, being able to manage a private cloud, but to some extent, especially when it comes to big data and data lake platforms, it's not really sufficient that you only operate your stack on top of a private cloud. And so in any case, full serverless, there's a lot of great services that you can consume off the shelf with an AWS that make things much easier. Like for example, Cognito for any kind of user authentication. You can use GraphQL. We've been talking about AppSync before. That's basically completely managed GraphQL interface that you can point to many data sources. And I think that's the beauty of it. Now, wrapping it up here, we all do this to actually execute interesting and helpful use cases on top of it, right? So we've been talking a lot about architecture, about infrastructure, but we have built out a couple of great products on top of the Cloud Data Hub, where we really enabled adjacent teams to be most efficient and effective. Here, one of the examples that you can see over here on the screen is the driver cockpit that we've introduced for a ride-hailing service. So essentially a taxi service where you always have this problem between the imbalance of supply and demand. What we've done is we've basically ingested the data in the data lake in real time. So we were monitoring our users' behaviors by using mobile analytics SDKs, and being able to digest all that data gave us the ability to really reason on top of such data and give recommendations in real time to where drivers should be placed next to be most effective and most efficient. We've also talked about connected fleet, so it gives us a lot of insights into how actually BMW drivers, and how many BMW drivers do we have here today? Raise your hands. Oh, at least a couple, right? So, yeah. It gives us a good indication of how people actually use their BMWs, of how they use the complex functions that you can find inside of our BMWs, and I think that's super interesting as well. Now we still have a little bit of time. I'd rather conclude, and I'd invite you for a separate offstage Q&A here next to the stage. Thank you for having us today. I hope that it's not going to take any longer for you guys, so you can go out and enjoy beautiful Berlin at this weather. It was a great pleasure for us to be here today. And well, thanks on behalf of the BMW Group.